Okay, so this is out. Excuse me. This is 712, which is writing exponential expressions as radical expressions and radical expressions as exponential expressions. So for this one, there isn't as many computations as in 711. It's just a matter of rewriting things. So hopefully you're following along with the handout, and you can see the objective is just to convert between the two, between exponential and radical expressions. And the big thing that we want to remember is power over root. And so this comes into play when we think about fractional exponents. So let's say we have some base and it's raised to a fractional exponent. So we've got a base of b and it's raised to an exponent of x over y. So y is your root and x is your power. So what that means is if we take this b raised to x over y, we can rewrite it in radical form, and we can say that this is the yth root of b to the x. Okay? So your number on the bottom, your denominator of your exponent, is your root, and so that's where we get square roots, cube roots, fourth roots, and so on and so forth. And then your number in your numerator, or the top part of your fractional exponent, is your root inside the radical. So a few things: if you have, let's say we have b raised to the a over 2, if your root is 2, you don't have to write it. So that's a square root. That's the same thing as having a square root. So this, you can write it if you want to, if that helps you calculate things better. So that's the second root of b to the a, or the square root of b to the a. So if you don't have a little number written here inside of your radical, you can assume that it's 2. Just like if we don't have an exponent, we can assume our exponent is 1. Okay? And so likewise, so then we can make a statement of like that, and we can say, well, if we have a root of b and it's raised to the power of 1 over x, so then that's the same thing as having the x root of b to the 1, or the x root of b, right? Because if your exponent is 1, you don't have to write it. So this is the same thing as an exponent of 1, and so you can put it in your radical if it helps you out, but you don't have to. Okay? So if you have b raised to the 1/2, well then you don't have to write anything, and that's just the square root of b. So that makes things nice and easy. So now we're just going to go ahead and convert some things. So we'll jump down to the classwork, and I'll start doing those examples. Okay, so for number 1, we have 2 to the 1/3. And so we have to rewrite this as a radical expression. Okay, so remember, power over root, so this is going to be the cube root of 2 to the 1, which is just the cube root of 2, right? Because when we have an exponent of 1, we don't have to write it. So for number 2, we have 7 to the 1/2, so that's going to be the second root of 7 to the 1st, which is just the same thing as the square root of 7, right? Because when your root is 2, you don't have to write it, and then when your exponent is 1, you don't have to write it. So for number 3, we have b raised to the 3/5, so that's the same thing as the 5th root of b cubed. Okay, so 5th root goes right here on the outside, and then your power of 3 goes on the inside. And actually, that's one way that I know some of my students in the past have liked to think about it. They might think about this as b raised to the in over out. Sometimes that phrase of in over out helps them, and then they have out root b to the in. Okay? So now we're going to start throwing in parentheses and constants and coefficients, and we'll get a little more complicated here. So for number 4, we have inside parentheses 2x raised to the 7/4. Now, both the 2 and x are in parentheses, so that means our exponent of 7/4 applies to both. So then this is going to turn into the 4th root of 2x to the 7th. And so this on the inside, we can simplify that, and we should. If you can simplify, you should. This turns into the 4th root of 2 to the 7th, x to the 7th, and 2 to the 7th, I'm blanking on what that is. I can check that on my calculator. 2 to the 7th, let's see, well that would be 16 times 8, 2 to the 4th times 8, 2 to the 7th is 128. So this is the same thing as the 4th root of 128 times x to the 7th. Alright, number 5, we've got a negative. So for number 5, we have negative 9a raised to the 2/3. Now, for this problem, we do not have parentheses around the negative 9 and the a. And the 2/3, because of that, the 2/3 only applies to the a, only the a. So what that means is our negative 9 goes outside the parentheses, and then inside we're going to have the cube root of a squared. Okay, so this is your answer here. Keep that negative 9 outside. Now, one thing I want to draw your attention to here. Notice how I kind of left this space between my negative 9 and the radical. And then the 3, I kind of have it inside the radical, inside that little fish hook like that. And you definitely want to make it clear that your root is your root and not your exponent on 9. If I had written this closer, or not use the fish hook, you can confuse your root here with being an exponent on the number on the outside. So you don't want to do that. Make it clear that your root is your root, and any exponents on the number on the outside are exponents. Okay? Alright, and then number 6. So for number 6, we have ab squared raised to the 1/3. Alright, so the ab squared are in parentheses, so then they're both going to be inside the radical. So we'll have the 3rd root of ab squared in parentheses, and the power on that is 1, because that's what we have right here. But if you have an exponent of 1, you don't have to write it, and we could say that this is the cube root of ab squared. So that's number 6. Now, numbers 13 through 18, we're going to do the reverse. We have things that are in radical form, and we're going to rewrite in exponential form. So for number 13, I have the square root of 15. So square root, so you can't see it there, but you can picture this as being the 2nd root of 15 to the 1, right? So we said anytime you don't have a root there, you can assume it's 2, and anytime you don't have an exponent there, you can assume it's 1. So then this is the same thing as 15 to the 1/2, because we have power over root. Okay? So for number 14, we have the cube root of y, right? And so you can think about this as the cube root of y to the 1, which is just going to turn into y to the 1/3. And then for number 15, I'll go to a fresh page for number 15. So for 15, we have the 4th root of 5y to the 5th. So we've got a bunch of things going inside this radical. So how we're going to break this down is we'll take the 5y to the 5th, and we'll throw it in parentheses, and we'll say that this is all raised to the 1 over 4. Okay, and then we would take this 1/4 and multiply it by the exponents inside the parentheses. So then this is going to turn into 5 to the 1/4 times y to the 5/4. And then that's your answer for 15. So then for 16, we have negative square root 2x cubed. Okay, so same process for 16. We'll have a negative on the outside. The 2x cubed will keep in parentheses, and because both the 2x cubed are inside the square root, we'll raise both of those to the power of 1/2. And then we take that negative, or we take that 1/2 and apply it to both of these. So then we have negative 2 to the 1/2 times x to the 3/2. And the reason why x is raised to the 3/2 is because you have a 3 on the x inside the parentheses, and you're multiplying that by the 1/2 on the outside. Alright, 17. So for 17, we have the negative cube root of 3x to the 5th. So same thing, I'll have my negative on the outside, take that 3x to the 5th, throw them in parentheses, and raise that to the 1/3. Okay, we keep our negative on the outside, and then the 1/3 applies to both the 3 and the x 5th. So that'll give me a negative 3 to the 1/3, and then x to the 5/3. And then that whole thing is your answer. So last problem, number 18. Alright, so for 18, we have the negative 4th root of 2x to the 7th. So we keep our negative on the outside, 2x to the 7th, throw that in parentheses, and that whole thing is raised to the 1/4. And then the 1/4 applies to both things on the inside. So we'll have, let's see, that'll be a negative 2 to the 1/4, and then x to the 7/4. So I did 1/4 times 7, and I get 7/4. And that's the end.